General math students, we're looking at angles of elevation and depression in this video. None of the mathematics is new. In fact, we're just going to be using some trigonometry that we've been learning in the previous videos. However, the context of the question has changed, so we're in more of an applied style situation. So, angles of elevation and depression. Well, an angle of elevation, like if you're in a boat at sea looking up at the top of a cliff, you look through an angle of elevation. If you happen to be at the top of the cliff looking back down at the boat, you look down through this angle of depression. Now, the important thing is that they're both measured from the horizontal. And in this case, the angle of elevation and depression are the same magnitude, so that means they're the same value. So if you're in a situation where someone's looking down at an angle of depression at an object, that object looks back up with an angle of elevation which is equal to that. That's an important thing to remember. Another common mistake is to say that angle of depression, when it's given, a lot of students like to put it here, but that's not right. The angle of depression is measured from this horizontal. Anyway, let's look at an example. And I've drawn a little picture here. You might want to pause the video at this stage and do a copy of this picture. I'm just going to do one little thing here, which I neglected to do, and that is I'm going to make this a dotted line. But aside from that, you might want to stop the video here and draw a picture of this in your book. Okay, so I'll have a go at it now. I'm going to fill in some of this information into this diagram. So, from the top of a lighthouse, 150 meters above sea level. Okay, so that means that from here, at the top of the lighthouse, down to the ocean, we've got 150 meters along that side. So that's the lighthouse that sitting on the edge of a cliff, this blue cliff I've got here. We all know cliffs are blue, of course. Okay, now it looks down at a boat. This is the boat down here, all right? And that is with an angle of depression of 58 degrees. So it's important I measure that from this dotted horizontal line. This is 58 degrees in here. And they want us to find the distance that the boat is from the base of the cliff. So this distance along this side. The other bit of information that we infer here is that the cliff forms a right angle when it meets the ocean. So we have a right angle triangle. So remember that fact I said about angles of depression and elevation being equal? I'm going to use that here to say that that's 58 degrees down there as well. And in class we may have spoken at this stage about that Z. See the Z that this forms? The Z, well, it's a backward Z, but you get the idea. So we've got those alternate angles there. I think that's the best way to go about it. There are other ways which you may use, but this is one good way. Now, this is a very nice artistic diagram we have here. Of course, this is not necessary for you guys to complete, these beautiful diagrams with excellent pictures of boats and lighthouses. Essentially, this forms this triangle, which I'm going to fill in some information over here, and always looks a bit clearer. Essentially, we are solving for D in this right angle triangle. And you guys have done a lot of these by now. That's much easier to pick all the bits out of. So, you might want to pause the video and try and solve and find the length of D, then I'll have a go. Okay, so we should be very fast at these now, and we should understand that this is a tangent situation and that the 150 meters is on top, which means it goes on top on the other side. D is 150 divided by tan, 58 degrees. So I'm getting 93.7 meters. Now, there's lots of different angles of elevation and depression questions for you guys to try. They will be slightly different to this one. There are nuances to these questions. So you've got to try lots of them to get that experience with all the different types of questions you might come across. Okay, so look in the description for the video for those.